Hi guys, my name is Trevor Sullivan and welcome to another CBT Nuggets skill. In this skill, we are going to be exploring a feature in the Kubernetes platform known as the Cluster Autoscaler. Now the Cluster Autoscaler is a really cool feature because we are going to be able to scale up and scale down the number of worker nodes that are inside of our cluster here. So as you probably know, a Kubernetes cluster is typically made up of your master nodes, and then you've got your worker nodes here, and the worker nodes are essentially responsible for running your application pods. And each of those pods can have more than one container, but for the sake of this particular discussion, you can just kind of assume that a pod just typically has a single container in it. Oftentimes pods will have other containers in there for logging or metrics gathering and that kind of thing. But in this particular case, just imagine that you've got a pod that has a single container inside of it, and that container is running some kind of web application, let's just say. Maybe an API server, maybe it's a web front-end server, something like that. But essentially what we want to do is to be able to scale up our infrastructure on a Kubernetes cluster so that as our applications running on our cluster are scaling up, we can accommodate the additional pods that are being spun up. Now I have another skill here at CBT Nuggets where we actually cover a feature known as the horizontal pod autoscaler, and that component is really useful if you would like to take a specific application component. Maybe you've got a website here that's running in a pod and you would like to create additional replicas of that web application inside of your cluster, and then have your service controller here do the load balancing of the network traffic that is coming into those pods. Now, in a similar vein, if your cluster or your application in this case had less traffic coming into it, you could actually eliminate some of those pods. So you could go maybe from 3 down to 2 pods. And that's what we call horizontal pod scaling, where we're increasing and decreasing the number of pods that make up a given application running on the cluster. There's also another method of scaling pods known as the vertical pod autoscaler, and that allows you to actually adjust the number of system resources, the amount of CPU and memory that is allocated to a particular pod. This can be really useful for any application components that are maybe monolithic in nature. So let's say you've got maybe a legacy application running in a container on a Kubernetes cluster, or maybe you've got something just like a single standalone database server like MySQL or PostgreSQL or something like that. You can basically take that single pod that's running that stateful application and then scale it up and increase the amount of system resources that it has. Now, the type of scaling that we're going to be focusing on in this particular discussion is cluster autoscaling, and this is different from the vertical and horizontal pod scalers because the cluster scaler is actually affecting the virtual machines that are running our pods on our Kubernetes clusters. So it's essentially allowing us to modify the worker nodes in the cluster dynamically. Now, the best value of this feature is going to come when you're using Kubernetes on a supported cloud vendor. And the cluster autoscaler is an open source component, and they have some pretty good documentation over here under the GitHub repository for the autoscaler that allows us to see the supported cloud vendors. So if you head over to github.com/Kubernetes/autoscaler. This is where you'll find the cluster autoscaler project, and you'll see it referred to in the documentation just as the CA. And in IT, it's really easy to kind of get your terms crossed, and so CA in this particular context is not referring to a certificate authority, which is a common theme when you're dealing with Kubernetes as well as applications running on a Kubernetes cluster for things like TLS encryption for your endpoints. However, in this case, CA is actually referring to the cluster autoscaler feature that allows us to dynamically size the number of nodes that are running on our cluster. So if we scroll down a little bit here, you'll see that there are a bunch of different supported cloud vendors here. And for this particular demonstration, I'm going to be using the Amazon Web Services Elastic Kubernetes Service, or EKS. It's very well supported, and I've actually tested out the cluster autoscaler on that particular platform, and I know it works pretty well. Plus, AWS has their own separate documentation that specifically talks about how to set up the autoscaler on their cloud specifically so that you can scale up and scale down your auto scaling groups. But there's actually, what's really interesting about the Autoscaler is that it actually follows the Kubernetes major release pattern. So as new versions of Kubernetes are coming out, the cluster Autoscaler feature is actually coinciding with that Kubernetes version that you're seeing here. So anytime that you see Kubernetes version come out, you're going to have a cluster autoscaler with the same major and minor versions here. And then the patch version is actually independent and allows the cluster autoscaler feature to be incremented kind of outside of Kubernetes directly. So what we can do is head over to the releases page. Let me find releases here. Not quite sure where that is in the interface here, but basically, I'm actually on the README file, I think. Well, if I just go to the root of the project here, I should see releases over here on the right-hand side. And then if we kind of scroll down through this list of releases, this is where you are going to see Cluster Autoscaler 1.22.2. You're going to see on the next page here, we've got like 1.21.2. And so because EKS is actually behind a couple minor versions in Kubernetes, we're actually going to end up using the 1.21.2 version here instead of the latest one, which is 1.22.2. So EKS just happens to be a couple versions behind. It's just kind of an implementation detail. The EKS team is kind of lagging behind the major releases of Kubernetes. So the most recent version of Kubernetes that they actually support in EKS is 1.21. And then the cluster autoscaler version that we're going to use here is the patch version 2. So there's a bunch of different supported cloud vendors here, as we saw just a moment ago. So that was actually here under the cluster autoscaler. So if you click into that, that'll actually take you to the cluster autoscaler folder in this project. And one of the things I almost forgot to mention is that when you're taking a look at the autoscaler project on GitHub, the vertical pod autoscaler is actually an add-on feature that you can install from here as well. The horizontal pod autoscaler is actually a resource that's built into Kubernetes directly. But if you want to install the vertical pod autoscaler or the cluster autoscaler, both of those features are actually part of this Autoscaler project here on GitHub. So as you can see, there's a bunch of supported cloud vendors here, and you've got all the major cloud vendors like Azure, AWS, and of course Google Cloud is in here as well. If we scroll down all the way here to the bottom, you'll see the list of supported cloud vendors, and we've got the Google Kubernetes engine listed in there as well. Now, if we head over to Google and just search for EKS cluster scaler or autoscaler, something like that, you should come across a document here called autoscaling. And this is going to show us all of the individual steps that we need to go through in order to implement this autoscaler. And then once the autoscaler is up and running, it will kind of take over and it will manage the worker nodes that are running on our Kubernetes cluster here. So if we basically, clean up all the pods running applications on our cluster, then the autoscaler might say, well, I don't need these 2 extra nodes here, and I'm just going to scale down to just 2 nodes instead of 4 nodes, because the cluster autoscaler feature will essentially see that by having over-provisioned numbers of nodes in our cluster, we're actually just wasting compute resources. So we've provisioned, 4 worker nodes in this particular case here, and we really only need maybe 2 of them. And that's kind of like our minimum baseline for worker nodes, so that if we do deploy a pod, that we wouldn't have to worry about waiting for the virtual machines here to actually spin up. So we can kind of set that baseline and say, I want a minimum. I will always want to have at least 2 nodes running on my cluster here. But if something happens where, you kind of start replicating these pods right up here, so if we kind of duplicate those a few times, now we've got maybe 6 pods running. And so the cluster autoscaler is going to see that we are requesting more and more resources from each of these pods in this application. So the cluster autoscaler will actually go over to the cloud provider's APIs for autoscaling, and it will actually tell the autoscaling group that we want to increase the number of nodes in the cluster, and the autoscaling group for that cloud provider will be responsible for adding in those additional nodes. Now, the autoscaling groups themselves are actually called node groups typically, and node groups isn't really a Kubernetes concept, but when you're provisioning clusters using managed cloud vendor solutions like GKE or AWS EKS or Azure AKS, then you are going to have this concept of a node group where basically you can create a set of nodes with common attributes. So in AWS terminology, these worker nodes here might be something like an m5.large instance type. Let me make that a little bit bigger here. So let's just say this is going to be like an m5.large instance type, and this could be one node group right here. And then separately, if we also wanted to have some other types of nodes, maybe we wanted to have C5 large nodes as well, we could kind of duplicate this and create additional node groups and create a different type of instance. So we could say, well, I want these to be C5 large instances. And you can even do the same thing for different operating systems as well. So if you said, well, I want these C5 large instances to be running, Windows and join Windows server nodes to your Linux-based Kubernetes cluster, then you could certainly do that as well. So the node group is basically just you can kind of think of it just as like an auto-scaling group, or in Azure terminology, like a VM scale set with a set of common attributes. And then the cluster autoscaler is actually going to go out to those autoscaling groups or node groups and basically tell them that it needs more nodes in order to satisfy all of the demand that's coming from the pods that an administrator or a developer in your team, in your organization, has requested to actually run on the cluster. So whereas the vertical autoscaler and the horizontal pod autoscaler features are going to deal with scaling up pods and scaling out pods horizontally, then the cluster scaler is actually going to be working at the infrastructure level here and actually manipulating the virtual machines that are supporting our Kubernetes cluster. So we're going to basically assume that you've already been able to provision a cluster using the EKSCTL command line utility, which is an open source tool. You can just head over to your favorite search engine and search for EKSCTL here. And if you're running on AWS, this is really the easiest way to spin up a Kubernetes cluster. Now, EKSCTL doesn't pre-install the cluster autoscaler feature. That's something that you'll have to do separately with these steps right here. However, this documentation does actually use the EKSCTL utility right down here. So it's really good if you've set up a cluster using EKSCTL, and then you can continue to use that utility in order to help install this feature and make sure that the autoscaler feature is up and running on your cluster. So let's go ahead and jump into our next video where we'll start the actual deployment process of the autoscaling feature on EKS. I hope this has been informative for you, and I'd like to thank you for viewing.